This lesson is going to be looking at simplifying radicals that are not perfect squares. Remember, a radical, for the most part, is a root. So if we're looking at the example here, it says the square root of 64. Remember, basically what that is asking is what number times itself can be given to multiply to make the number underneath the square root sign, which is the 64. So most frequently what comes to mind is 8, because 8 times 8 is 64. But remember the rules of integers, a negative times a negative also can give you a positive number. So negative 8 times negative 8 also gives you positive 64. Therefore, the answer, technically, the square root of 64 is both positive and negative 8. 64 is what we consider to be a perfect square because it has a square root that is a rational number. And remember, a rational number is a number that you can write as a fraction. So for the radicals that we're looking at here is basically a perfect square, or a rational number is the square root that can be taken and give you a whole number answer. But let's take a look at, say, instead of 64, let's do 63. If we did the square root of 63, can you think of a number times itself that gives you 63? Right? Because 8 times 8 gives you 64. So if we go less, the next number less than 8 is 7. 7 times 7 is not 63. 7 times 7 is 49. So therefore, there is no whole number or a number that we can write as a fraction that gives you the square root of 63. So that's what we consider to be an irrational number. However, even though it is irrational, we can still simplify it, kind of like we simplify a fraction. So there are two properties in order to help us simplify radicals. The first one is the product property. If you have a number that's underneath your radical symbol, you can break it down into a multiplication problem, the two factors also underneath the radical symbol. So for example, the square root of 63. If I'm thinking about two numbers that multiply to make 63, I want one of those numbers to be the biggest perfect square possible. So if I take 63, my biggest perfect square that goes into 63 is 9. So I'd have the square root of 9 times the square root of 7, because 9 times 7 is 63. One of those two things we can do. We know the square root of 9 because 9 is a perfect square. The square root of 9 is 3. So I do not know the square root of 7, so my answer would be 3 square roots of 7. The quotient property is similar to the product property. Instead of multiplication, however, it's division. So if you have a division problem, or otherwise known as a fraction, underneath the square root symbol, you can simplify it by taking the square root of the numerator of the fraction and dividing it by the square root of the denominator of a fraction. So if we're looking at the example, the square root of 9/25, I can simplify that and say the square root of 9 over the square root of 25, each piece separately. And then I can evaluate both. The square root of 9 is 3, and the square root of 25 is 5. So my final answer simplified would be 3/5. So when you're simplifying radicals, just like when you're simplifying a fraction, you want to break it down by the biggest perfect square possible. So these are my first 20 perfect squares. So let's take a look at 44. If we're thinking about that list of perfect squares, I want to break this down into the biggest number that I can. So the biggest number that goes into 44 is a perfect square. Remember, my perfect squares less than 44 are 1, 4, 9, 16, 25, and 36. So the biggest one that goes into 44 would be 4. So I could say that the square root of 44 is the same thing as the square root of 4 times the square root of 11. One of those two things we know we can do the square root of 4. The square root of 4 is 2. So my answer here, simplified, would be 2 square roots of 11. Then if we did 32. So again, my first couple perfect squares are 1, 4, 9, 16, 25. Those are the ones that are less than 32. So the biggest one that I could use would be 16. So I could break this down into the square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2 we don't know, so my answer then would be 4 square roots of 2. Now take a look at something for a moment, because if we're looking at 32, there are other perfect squares that go into 32. 4 goes into 32, right? So let's say hypothetically that we broke down the square root of 32 this way. If we broke it down into the square root of 4 times the square root of 8. That's fine, but just like with a fraction, you would have to simplify more than once if you didn't use the biggest common factor. So if I simplified this, I know the square root of 4. That's 2. But I don't know the square root of 8. So far it's just 2 square roots of 8. But then looking at the second number, the number still underneath the square root sign, which is called the radicand, if I'm looking at the radicand, I can still simplify it by one of those perfect squares. That's the 4. So then I could say that this is 2 times, then I have to break up the number underneath the square root sign, the radicand, even further. So it'd be the square root of 4 times the square root of 2. I can then evaluate further, because I know the square root of 4, that's 2. So I would have 2 times 2, square roots of 2. I don't know the square root of 2, and the square root of 2, the only number in perfect squares that I could break it up to with is 1, and that's not going to help anything breaking anything up by 1, because it would give you the exact same answer. I then would have to combine my numbers outside my square root. That would give me 4, and that would end up being the square root of 2. So just like with a fraction, if you don't divide it by the biggest common factor first, you have to simplify more than once. That's why I recommend looking at the biggest number in your list of perfect squares that you can divide by before starting, because otherwise you have to keep going and going and going, and that could be multiple times depending on how large your original number is. And then let's take a look at one example with the fraction. Just like the property of power or quotient said, you can break this down into 2 square roots on top of each other. So it's the square root of 27 over the square root of 36. If we break down the numerator, we have the square root of 27. That can be, remember our perfect squares are 1, 4, 9, and 16, and 25. The biggest one of those that can go into 27 is 9. So I could say that 27 is the square root of 9 times the square root of 3. And then notice that the denominator is a perfect square. The square root of 36 is 6. So now I have to simplify the numerator part. I know the square root of 9. The square root of 9 is 3. So I have 3 times the square root of 3, which I don't know the square root of 3, so I have to leave it, over 6. Now if I'm just particularly looking at the fraction part, if I ignore the square root part for a minute, if I just had 3/6, I can simplify 3/6 as a fraction, because my biggest common factor would be 3. So 3 divided by 3 would give me 1, and 6 divided by 3 would give me 2. So that's the same thing as saying 1/2. And remember, 1 times anything is just 1, so I really wouldn't have to write 1 square root of 3 over 2. I could just really say that my final answer is the square root of 3 over 2, because I still would have to have simplified that original fraction. So this would be my final simplified answer, square root of 3 over 2.